Hi guys, this is Mr. Crowther here, one of the Algebra 1 teachers. You've heard my voice before in some previous videos. Today we are going to look at graphing systems of equations and solving them by substitution. We want to do some review with you this week to make sure that we're all confident and capable of using these two methods to solve for a system of equations. So there's a couple different ways we can look at it. And obviously we have technology, and I'll jump into that in a little bit. But I want to stress that we should be able to be graphing lines by hand. So we're going to take a look right here with these two equations. Now, one of the confusing things I'm starting to see in my work is what is a system of equations? Well, a system of equations just means more than one equation that has a single solution. So we are looking here at two separate equations, and the solution is going to be the value for x and y that is true for both of the equations. It's got to work for both, not just one or the other. When we're graphing them, this is easily identifiable as the point of intersection. So let's take a look. So the first one I will do in black. Now, if you remember this plus 3, that's my y-intercept. So I'm going to go to plus 3 on the y-axis as my starting point. And my slope, my rise over run, my change in vertical over change in horizontal indicates where to go to find my next point. Because it's negative, I'm going to go down 5 first. 1, 2, 3, 4, 5 to negative 2, and then right 3. I only ever need 2 points to make a line. So I have my 2 points, so I'm going to connect them with a straight edge. For my second equation, I'll do it in green. So I'm going to start at negative 3 as my y-intercept. My instructions, my slope says go up 1, right 3. Again, using my straight edge. I'm going to connect the points. And so when we graph it, it's pretty easy to see where they intersect at this red point right here. Now our answer will be written as an ordered pair. So remember, an ordered pair is x comma y. The x goes first, the y goes second. So to get to this point on my x-axis, I have to go right 3, which is a positive, and then down 2, which is a negative. So my solution for this system would be 3, negative 2. That is the point that makes both equations true. So let's check out a second example here. I have y equals 4x plus 3, and y equals negative x minus 2. Now, if you're not confident with graphing or are still working on graphing, we can still use tables and see if we can get a value that way. I will start with some x values, and I like to start with negative 2 to 2 because it'll give me an idea of the pattern that's happening in both directions should I need to expand my table. So when I put negative 2 in for x in the first equation, negative 2 times 4 is negative 8, plus 3 is negative 5. Negative 1 times 4 is negative 4, plus 3 is negative 1. 0 times 4 is 0, plus 3 is 3. And I'm starting to see my pattern that I'm increasing by 4 every time, which is my slope, which makes sense, my rate of change. So in theory, the next number should be 7. 1 times 4 is 4, plus 3, I do get 7. 2 times 4 is 8, plus 3, I get 11. My pattern holds. So when doing my table for the second one, again, I'm looking for same x and same y value. So I'll choose the exact same x values. And then I'm going to put them in. Here I have to remember that the negative means the opposite. So when I'm taking the opposite of -2, I get a +2. So when I put -2 in for x, -2 is +2 minus 2 is 0. When I put -1 in, -1 is 1 minus 2 is -1. When I put in 0, I get -2. My slope being -1 should mean that my numbers are decreasing by 1 every time. That pattern seems to be holding. -1 minus 2 is -3. And -2 minus 2 is -4. So just looking at my tables right now, at the point -1, -1, it is true in both equations. So the solution to this system will be -1, -1. If you find that tedious, a little too long to do out, then we can always graph it. So starting with the first equation with a y-intercept of 3 and a slope of 4. So I can't go up 4 and right because I'd be off my graph. So I'm going to go the opposite. I'm going to go down 4 to -1 and left 1. And then connect my dots with a straight edge. And then for the second graph, I'm going to start at -2. And then I'm going to go down 1, right 1, as my slope is -1. And then I'm going to connect my dots. And I can see my intersection point on the graph is right here. And it is, in fact, at -1, -1. So it worked. We did it with the table, we did it with the graph, we got the same solution. So the final way I wanted to show you was what happens if it's not set up super nicely in that y equals form, which is the slope intercept form. And it's in this form, which is known as the standard form. Again, you have a couple of options if you want to graph these. The first is to change it into y equals form. This involves manipulating my equations. So if I want to get y by itself, I need to subtract 5x from both sides. So I get y equals -5x plus 4. In the second one, I have x minus y equals 2. I'm going to subtract x from both sides. And then I have to multiply both sides by -1 to get y to be positive. And I get my two equations in that slope-intercept form, that y equals form that you are familiar with graphing. Now that's a little bit of extra work, but it still allows me to do the job. The way I really like to work with these is to get 2 points. And for me, the easiest 2 points are going to be where it crosses the y-axis and where it crosses the x-axis. So for the first one, I know that if I put in 0 for x, I will get my y-intercept. So 0 times 5 is 0, which means y equals 4. It's pretty simple. To get my second point to draw my line, I'm going to put 0 in for y. If I put 0 in for y, I'm left with 5x equals 4. So to solve for x, I just have to do this one-step equation, divide by 5, and x equals 4/5. So I have 2 points. I can graph a line. I can do the same thing with my second, and this one's going to be even easier. If I put 0 in for x, I'm going to have negative y equals 2. Multiply both sides by negative 1, I'm going to have y equals negative 2. If I put 0 in for y, I'm going to have x equals 2. X minus 0 equals 2, so x is 2. 2 points, all I need to graph a line. So again, another different strategy to find 2 points to manipulate your equations, or we could also create a table for both and insert our values. Let's graph and see what our answers will be. So my first equation and my second equation. And I see they intersect right here at the point 1 comma negative 1. That is the solution to the system of equations. Again, we always have the option digitally in Desmos. So I could put in any 2 equations. When using Desmos, I'm always going to use y and x as my variables. So even if the variables are different in the problem, you're going to make them y and x because that's how Desmos reads this problem. So let's say I have y equals 3x plus 7. Y equals negative 4x minus 9. Desmos allows me to click on the intersection point, and although this one isn't very pretty, it's accurate. And again, the red indicates the red line, the blue indicates the blue line. What happens if I were to change this y-intercept to negative 33? Well, the intersection isn't on my screen. So I have some options. I can move my graph until I find an intersection point, and then I can click on it. Or I can always go to my wrench and change my y-axis and x-axis views. This is also the place where you would add a label if you were using something from context and we were talking about the number of hours versus the cost of a car. And you'll see it types them directly onto the X and Y axis. So when you take your screenshot, you have labeled axes, which is crucial, as well as adjusting a scale. We don't want a scale that's like that, because that looks like it intersects right at 0, 0. So we want to make sure we have a nice accurate scale That allows us to see the intersection point. And even if we have to estimate, I know it's going to be close to -6, -10, which will help me in the long run. So hopefully that's been a quick review for you on the graphing. And now the next video will go into substitution.